Hi, today I am going to discuss about a red block tree. What is a red block tree? So red block tree are a variation of a binary search tree to ensure that the tree is balanced. Height is O of log n when n is the number of nodes and the operation take O log n times is the worst case. So published PhD supervision. So next one is a hysteresis or value laziness. Hysteresis is a retradition's effect of the forecasting acting upon the body and or change, especially is lagging in the values of resulting magnetization and magnetic material due to change magnetic force. So binary search tree plus 1 is a bit for node is attribute color which is the red or black. So all other attribute of the BST are inherited key left, right and P. So empty tree leaves are colored black. Where use the single sentinel nil, all the leaves are red black tree. So with color nil equal to black. It's a red black property. Every node either red or black. Is a root is black. Every leaf is nil. The black. So node is red. The both children are black. So for each node, all the path from the node to descendant and leaf contain the same number of black of node. So red black tree example. This node is. So let us assume that the blue color is considered as a red. Remember, every internal node has two children, even though his nil leaves are not usually shown. Can construct one nil nodes is connected to everyone, and height of the red black tree is height of the node h of x is the number of edges, longest path of the leaf, and next one black and height of the node x comma ph of x. Ph of x equal to number of black nodes including nil of t on the path from x to leaf, not counting of x. Black height of the red black tree is the black height of his root with the property of the 5. Black height is well defined. So example, height of the node h of x equal to edges in the longest path of the leaf. Black height of the node bh of x equal to black node is a path from x of x to leaf, not counting how they are. bh of x is less than or equal to h of x less than or equal to 2ph of x. You can assume that the height equal to 4, 1 2 3 4, height equal to 1. This is only one node, birth equal to 1. So bh2 bh1 and bh1 bh1 h1 bh1 and rb is a height. So consider the node x rb tree. The longest descending path from x to leaf the has the length h of x, which is the most of the twice length of the shortest descending path from x to leaf. So black nodes on any of the path from x ph of x in the and is less than or equal to node on the shortest path x comma s of x. So but there are no constructive red proper 4. So bound on the rb tree height. So lemma proof the subtree is rooted of the any node x as the greater than or equal to 2ph of x minus 1 internal node by including height of x. The sub cases, the base case and in induction step. Base case height of hx equal to 0, x is a leaf, bh of x equal to 0, subtree has 2 power 0 minus 1 equal to 0, and induction step height h of x equal to h is greater than equal to 0 or equal to or 0. Each child x has the height h minus 1 and black height of either b. Child is red, b minus 1 is child black. And next one is a lamna is a red black tree with n internal nodes of the height are at most 2 lg plus 1. By proof above the lamna is a n greater than or equal to 2ph of minus 1, and since ph of less than or equal to h divided by where have the n greater than or equal to 2 power the h divided by 2 minus 1. and operation of arbitrary. All the operations can be performed O of log n time. The query operation which do not modify the tree are performed in exactly same way there are in the BST. The insertion and deletion are not side forward y. So rotation, left rotation, right rotation. So left rotations x, y, z, alpha, beta, gamma, and left rotations is right of x equal to left of y equal to nil of t, then p left equal to y of x, p of x equal to y, p of x equal to nil, the root t of y, class x equal to left of px equal to y, else right of px y. So left of y equal to x, p of x equal to y. So left rotations and then right rotation. So pseudo-code of the left rotation, let us in that rotate the x and makes the left child y and left subtree y to right subtree x. Pseudo-code for right rotation symmetric exchange in the left and right vary where so O of 1 is both left rotation right rotation since the constant number of pointer are modified. So every node either the red or black, the root is black. So every leaf is a nil is the black. If a node is red, the both children are black. You see, for each node all the path from the node to descendant leaves contain the same number of black nodes. Insertion arbitrary. So use the tree insertion insert from the BST. So slightly modified insert the node x into T. RB insert is a color the node of X red. So Fixup modify the tree, recoloring the node, performing that RB insertion is a nil T, root T, while condition you have to check it. After that executed, you have to check it at the if loop, the insertion point. How does if different from the tree insert procedure, the PSD? When which of the RB properties moved, red black tree property moved. So insertion, Fixup the problem. We have the one pair consecutive the red way did the insertion solution, rotate the tree anyway. So insertion, while color you have to check red, the left one and right one is a left is a black, then black. So what are the cases of the possibility, red or black? So insertion node, else if right of here color y not equal to red means left rotate or otherwise right rotate. So condition there are two possibilities. Loop invariant. Loop invariant at the start of the each iterations while loop z is a red, p of z is a root, then p of z is a black. There is at most red black violation property 2, z is a red root and z and p of z is a both red. That cases what will happen, the terminate the loop is terminated. So last line is ensure that property always hold. The maintenance we drop out the when z is root, p of z is the essential nil of t is the black. When we have the start the loop body, only the violation of the property where 6 cases 3 cases symmetric together, the other consider the cases. You can just see the diagrams. So see, so black A B D is a red, you have to rotate it. P of PZ is a grandparent of the black, the red, and no other variation properties. Case 2, Y is a black, Z is a right child. What will happen? Rotate around that, switch the role in the left child, both are red. Make the P of Z and P of V of Z right rotate in the ensure the properties maintain the no longer have to the red in arrow. So algorithm analysis is RB insertion, each iteration O of 1. So move to the Z level 2. And deletion like the insertion should be preservation RB property. The property that you have the violated depend upon the color and deleted red okay, black. Step to BST deletions. So left z equal to nil is our right nil is a else tree success, left of nil, then left and else right p of x and p of y deletions. If y del t root t, left p of y, left p of y, right p of y, then key of z, the color y black RB delete. So find up t comma x. So RB property violations. So property 1 okay, property 3. Property 2 is a root and x is a red. The root has become the red. The violation p of y exit both the red in the path containing now has the one fewer black nodes. So any path containing the y now has one fewer black nodes, extra black. So correcting given the x and the extra black, one count is a black node that both contain the x. Property 5 is okay, the property 1 is not. So double black is a red and black. Deletion fixed up, you have to check that the tree is empty or not, otherwise you have to left or right switch to black. The black means case 1, red means case 1, and left rotate case 1, right rotate case 2. Okay, so if your black is a case 3 and right rotate case 3, and color you have to check it out, left rotate. Deletion fixed up. Within the while loop is the non-root is a double black node cannot be nil of descent would have violated the property 5 at px cases. Case 1, p of d w only one black node other than that red node. So only one new nodes how to insert this case of children. Case 3, while the black left child is a red, w is a right child in the black. Case 4, w is a black, w is a right child is a red. Analysis RB delete fixed up, RB delete fixed up. So within the fixed up, move to the up one level. Each of the cases 1, 3, 4, 1 faces rotation. Value lazyness. Still or not the free balancing cost some of times insertion and deletion. That's all about it. See you. We will meet in the next class. Bye bye.